Can you imagine what would happen if a massive asteroid were to hit Earth? The devastation and chaos that would ensue would be unimaginable. This is a very real threat that scientists around the world are working tirelessly to prevent. Asteroids have the potential to inflict massive devastation if they were to ever collide with Earth. But thanks to advances in technology and scientific research, there may be hope for preventing those devastating impacts from occurring. In this video, we will explore the DART project and learn how it aims to protect us from asteroids through advanced tracking systems and other innovative technologies. So join us as we explore all this and much more about the threat of asteroid impacts and what we can do to prevent them. Let's go! Asteroid impacts pose a significant threat to Earth, as they can cause devastating damage and even wipe out entire civilizations. These large space rocks were produced from the remaining dust particles left over from the planets during the formation of our solar system. They can range in size from tiny specks of dust to massive boulders that measure several kilometers across. One of the biggest dangers posed by these objects is their extreme speed. When traveling through space, asteroids often have velocities that are many times greater than the speed of sound on Earth. This means that if an asteroid were to crash into our planet, it would most likely hit with tremendous force, causing widespread destruction and loss of life. Another major risk is that most asteroids contain material like iron or nickel, which can be converted into harmful substances like radiation and toxic gases when they burn up in our atmosphere. Given these risks, it's clear that we must do more to protect ourselves from asteroid impacts. This can be done through a combination of efforts, including developing advanced detection technologies, building robust planetary defense systems, and proactively diverting any potential threats away from Earth. With careful planning and cooperation across borders, we can ensure the continued safety and prosperity of our planet for generations to come. The current approach from NASA is the Double Asteroid Redirection Test, or DART for short. It aims to use kinetic impactors to deflect potentially hazardous asteroids. The project was originally conceived in 2005, and it's seen continued progress since then. DART uses high-precision targeting capabilities to accurately target an asteroid and avoid any potential for accidental damage on Earth. Scientists believe this method of planetary defense could help us prevent devastating impacts of future asteroid strikes. Overall, DART is a promising approach to protecting our planet from the risk of large-scale asteroid collisions. Recently, the DART project successfully carried out its first planetary defense mission. With the help of highly accurate targeting systems, scientists were able to direct a kinetic impactor at an asteroid known as Dimorphos. The impact caused Dimorphos to change its trajectory, demonstrating that DART is capable of deflecting potentially hazardous asteroids. This accomplishment was a major milestone for the DART program, and it's inspired further research into this promising area of planetary defense. Overall, the successful test shows that we've developed effective methods for preventing asteroid impacts from occurring in the future. The impact of DART on the asteroid Dimorphos has been a major success, demonstrating the potential effectiveness of this approach in protecting our planet from potential collisions with asteroids. Prior to the impact, Dimorphos took 11 hours and 55 minutes to orbit its parent asteroid Didymos. However, through measurements taken after the collision using ground-based telescopes and radar facilities, astronomers have confirmed that DART's impact reduced this time significantly, shortening Dimorphos' orbit to just 11 hours and 23 minutes. In addition to measuring the precise change in Dimorphos' orbit, researchers are also studying the ejecta from the impact in order to better understand the dynamics of the collision and its impact on momentum transfer between DART and the asteroid. Overall, this mission has demonstrated the potential effectiveness of DART as a tool for protecting our planet from potentially dangerous asteroids. While much work remains to be done, it represents an important first step in understanding how we might one day use such technologies to help protect ourselves from these cosmic threats. The DART mission was also equipped with a camera, or LISHA-cube, which is a small CubeSat that was piggybacked with the DART mission to study the effects of the spacecraft's impact on its target asteroid. Designed and built by the Italian Space Agency, LISHA-cube was a passenger and separated from the mission 5 days before the collision. Once separated from DART, LISHA-cube began collecting data about the asteroid's orbit and changes following the collision. With its advanced imaging capabilities, the camera is able to provide detailed measurements of Didymos' surface features and help assess how much momentum was transferred by DART's impact. It also captures high-resolution images that can be used to study changes in the asteroid's rotation and how much debris was ejected by the collision. One method scientists use to detect asteroids that could potentially impact Earth is through the use of advanced telescopes and sophisticated imaging technology. These instruments allow researchers to monitor space for signs of incoming asteroids and track their trajectories in order to predict potential impacts with Earth. This enables them to issue warnings about potential asteroid threats so that we can take protective measures, such as diverting or destroying the asteroids before they have a chance to collide with our planet. Additionally, scientists are continually working on new ways to improve our ability to detect and track asteroids, including developing next-generation telescopes that have even greater resolution and sensitivity than current systems. By staying vigilant and continuously improving our detection tools, we can help ensure that we're able to protect ourselves from dangerous asteroid impacts in the future. The threat posed by asteroids is a serious one, and it's important that we do everything we can to understand this risk in order to ensure the safety of ourselves and our planet. To avoid another catastrophic asteroid impact like the one that wiped out the dinosaurs 65 million years ago, we need to better understand these objects and how they interact with our planet. By investing in research on asteroids and developing technologies like DART, we can work proactively to mitigate the risks posed by these dangerous objects. So don't start worrying about asteroids just yet. Let's work together to ensure the safety of our planet and all who inhabit it. With increased awareness, education, and action, we can avoid the next big asteroid impact and protect ourselves from this deadly threat. The history of asteroid and meteorite impacts is a long and varied one, spanning thousands of years and covering a wide range of impact events both large and small. Some of the most prominent impacts in human history include the Tunguska event in 1908, which devastated hundreds of square miles of Russian forest, the Chicxulub impact that wiped out the dinosaurs 65 million years ago, and the Chelyabinsk meteor explosion, which occurred just over 9 years ago in 2013. These impact events all have several things in common. Firstly, they demonstrate just how powerful asteroids can be, with their impacts leaving devastating effects on Earth's ecosystems and wildlife. Secondly, they highlight the importance of taking preventative measures to avoid future asteroid impacts. And thirdly, they serve as a powerful reminder that we need to take asteroid impacts seriously and actively work toward developing strategies and technologies that can help us detect and deflect incoming asteroids. What if an asteroid were to hit the Earth? The impact of such a devastating event would be catastrophic, with major events in our environment, food supply, and human civilization as we know it. First of all, an asteroid's impact would cause immense damage to our planet's ecosystems. The intense heat and pressure generated by the collision would kill off much of the life around it, destroying forests, marine habitats, and animal populations. This could have a ripple effect that disrupts entire food chains within our ecosystem. Additionally, an asteroid strike could cause significant disruptions to our global food supply. Crops could be destroyed or made inaccessible due to damage from the impact or its aftermath. Many animals that are important sources of food for humans may also go extinct in the aftermath of such an event, further threatening our ability to feed ourselves. Finally, an asteroid strike could have major implications for human civilization as we know it. Infrastructure like roads, buildings, and power systems would likely be damaged or destroyed in the impact, leaving many people without access to basic necessities like food, water, and shelter. Economic activity would also grind to a halt in the wake of such an event, with major repercussions for the global economy and international trade. In short, if an asteroid were to hit Earth, it would cause immense damage to our planet and its inhabitants. We must take all possible steps to prevent such a disaster from happening in the first place, both for our own sake and for future generations. In conclusion, it is clear that asteroid impacts are a serious threat to our planet and its inhabitants, and we must take proactive steps to prevent them from happening. By investing in research on asteroids and developing technologies like DART, we can work proactively to mitigate the risks posed by these dangerous objects. So let's not wait until it's too late. Let's come together as a global community and work toward protecting our planet from future asteroid strikes.